Hello everyone, my name is Jason Wien, and today I'd like to present to you my project called MarketPlacer, Understanding the Landscape of the Etsy Ring Market. There are over 1 million rings for sale on Etsy in all sorts of styles and varieties. How can anyone make sense of such a huge landscape? Luckily, Etsy further subdivides the rings into categories to help buyers and sellers understand what's out there. Now, the current categorization spans the entire price range of rings, from rings as low as a few dollars to rings for as high as $250,000. If you think about it though, the types of rings that are offered changes dramatically as you change price points. Therefore, I decided to use machine learning algorithms to learn new categories for the lower end ring market and see if any market insights could be gleaned from having a better categorization. Using Etsy's API, I collected almost 200,000 active listings for rings between $10 and $50. For my project, I decided to focus on text descriptions with the possibility of adding more features like image data at a later date. To learn the new categorizations, I used an unsupervised learning algorithm called latent Dirichlet allocation, or LDA. The output of the LDA algorithm is a ranked list of words commonly associated with each topic. And from this ranked list of words, I inferred a human interpretable list of categories. In this way, I found 5 categories that rings in the lower end market tend to fall into. As LDA is an unsupervised algorithm, it can be difficult to assess how well you did, as there's no obvious choice for ground truth. For example, how many categories are there really? A statistical way to answer this question is to compute the perplexity, which essentially captures how confused is your model when it encounters ring descriptions it has never seen before. After various rounds of testing, I found that the perplexity was minimized for 5 categories, and that's the number that I chose. So all this worked great, but I wanted to dive deeper and see if there were any business insights that could be derived from having a better categorization. To do so, I focused on a case study around the question, what types of rings are popular? I defined a ring as being popular if it got in the upper quartile of the number of users who favorited the listing. For my data set, this was 30. If we look at the breakdown by category, we see some interesting things. On the left, I show the distribution of listings among categories, so what percent of listings fall in each category. On the right, I show the percent of each category, the percent of listings in each category that are popular. One of the first things that might jump out when you compare these two charts is that stamped engraved rings tend to be quite rare. They're only 7% of all the listings in this price range, except they have way above average popularity. This signals it might be an interesting opportunity for a new ring seller to enter the market in this space. Conversely, vintage rings are the most common, and they are less popular than average, which might suggest that the vintage ring market is oversaturated. I communicated all of these insights to sellers through a web app. The web app takes a text description of rings, uses LDA to match it with the correct category, and also gives some more marketplace analysis. We can see how this works live. This is my website, jasonwien.com/marketplacer. If you scroll down, there's a field to describe a ring. And just as a test, we'll use personalized name ring. See what we get. And it matches 60% with the category stamped engraved, which matches with what we would have expected. If we scroll down, then there's a further breakdown of all the categories that it matches with, as well as some more marketplace analysis available for sellers. In conclusion, I developed 5 categories for rings in the $10 to $50 market on Etsy through LDA topic modeling. I communicated these insights to sellers through a web app. Looking forward, I can use these engineered text features in a popularity classifier to help sellers determine how best to reach the most number of customers. A prototype that I built had a 64% accuracy, but I'd love to add more features like image features and other things like that. A little bit about myself. I'm a theoretical physicist and rock climber turned data scientist. I have degrees in physics from Harvard, the Perimeter Institute, and UC Santa Barbara. My most recent research focused on numerically solving differential equations to study black holes with funny shapes in the interior, like that one. Throughout my career, I've loved diving deep into a complex toolkit to solve problems. In my spare time, I like to rock climb, and this was my brother and I after we climbed Half Dome. Thank you.